Hello students, so in the last lecture I was discussing about 8051 microcontroller architecture, and there I was discussing about the stack memory and the stack pointer. So I'll be continuing with the same topic in this lecture also. So now I've told you this stack memory, when the microcontroller is powered up, when this 8051 microcontroller is powered up, to avoid overwriting avoid overwriting the default register bank, that is bank 0, the stack pointer register by default stores this address 07, so that the stack memory gets started from 08H. Therefore 08H to 1FH in the 8051 microcontroller RAM can be used for stack memory. Now the upper limit 1F, the upper limit is so. Why the upper limit is 1F only? Why it cannot extend? Because the internal RAM memory is from 00 to 7F. So why the upper limit is 1F only? The upper limit is so because 20 to 2FH of RAM, like this 20 to 2FH of this internal RAM, these are reserved for bit addressable memory and must not be used by the stack memory. So if in a program, what will happen if in a program more than 24 bytes of stack memory is needed? As you can see, 08 to 1F will make up only 24 bytes. Like 08 is 1 byte, 0, this is a 1 byte memory location, this is another 1 byte memory location. Like from this 08 up to from the address 08H up to the address 1F, there are 24 bytes of memory location. So if in a program more than 24 bytes of memory location or stack memory is needed, then what is the solution? We can change the stack pointer to point to RAM location 30 to 7F. So this stack pointer is also user accessible. If you need the stack memory to be more than 24 bytes, we are seeing that this is only making up 24 bytes, like 08 to 1FH address is only making up 24 bytes of memory location. So if our program needs more than 24 bytes of stack memory, then we can change the stack pointer to point to any RAM location 30 to 7FH. Now what will happen when data, now I'll be discussing about the stack operations like push and pop operations. So this is the stack pointer register. I told you the stack pointer register is a 8-bit register. So now let me discuss the push and pop operations. So when the data is to be placed on a stack, we call it a push operation. Whenever we want to place any data on the stack memory, that operation is called push operation, and we need push instructions. So what will happen in the whole procedure, when suppose this is a stack memory, and this is the latest address which is being used for storing data in the stack memory. So this is also stored, this is also stored. So this location is also stored with the data. So this is the recent location where the data has been stored. Now if we want to place any data on stack by push instruction, the content, so this address will be stored by the stack pointer, because this is the recent location that where the data has been stored in the stack memory. So what will happen if we want to place any further data on the stack memory by the push instruction? What will happen? First, the content of the stack pointer will get incremented by 1. So it will get incremented by 1, it will point here, and what will happen? The data will get stored on the stack. So this is how the push instructions work, and this is how stack pointer operates. Now what will happen when data is retrieved from stack? Suppose this is the data and I want to retrieve any data from the stack. What will happen? The byte, that data, that is the byte, because it is a byte location, so whatever that data is read from the stack where the stack pointer is recently pointing. So where the stack pointer is recently pointing, that data will be read from the stack or retrieved from the stack memory, and the stack pointer will get decremented by 1 to point to the next available byte of the stored data. So initially stack pointer was pointing to this location, this data is retrieved. Now stack pointer will be decremented by 1. Now this will point to this address, and this will be the data here. So this stack pointer is decremented by 1 to point to the next available byte of the stored data. So this is how stack pointer and stack memory works. So I'm ending this class here. We will continue with the same topic in my next lecture also. Thank you.